Okay, that should be working now. Good morning, everyone. I hope you are still enjoying the conference. It's been amazing day yesterday, and hopefully it will be also really amazing day today. Uh, yeah, well, the sponsor obligations are done, so let's switch to my actual title slide. Uh, my name is Krzysztof, or Christopher, for those of you who don't speak Polish and are unable to pronounce this super sounding strange name. And I'm here to talk to you today about artificial intelligence. I work as a principal research engineer at Microsoft/GitHub, and I'm part of the organization called GitHub Next. GitHub Next is a R&D, research and development team inside GitHub. We operate separately from the company. As you know, big companies can have those like processes and all this bureaucracy. So we try to operate as a startup separately to the company, and we try to investigate the future of software development. And oh, in my talk there will be those like QR codes everywhere that goes to different links with additional information if you want to investigate more about like what I'm talking about. So GitHub Next is a group of 15, 16 researchers and developers. And yeah, we try to figure out what's the future. And the future usually is about artificial intelligence, but not only about artificial intelligence. You may have heard about some of our projects, like GitHub Copilot. That's probably the one that's mostly well known right now. And we had a lot of like interaction yesterday and like hands, getting raised. So I will ask you a couple of questions. Are there any data scientists in the room? Oh no! Please make sure that you don't throw any like tomatoes at me or anything like that while this talk is happening. Uh, okay, so the second question: who here is able, using their computing programming skills, do a web request? Everyone? Everyone? Okay. And string concatenation? Perfect. You're all now can be AI engineers, data scientists, whatever. So we live in this really interesting point in the time where integrating AI into your application is just as simple as doing single web request and figuring out what is the right input that you should send to the AI and what is how to process the output. You don't need to know too much about models. I'm not data scientist. I'm software developer, as probably most of us in this room. If I would have to describe one of my specialties, it would be like user experience actually, or like developer experience. That's what I've been doing for like last 10 years of my life. So I don't know much about models. Of course, there is also the product side of things, building the business case, figuring out how to charge you all money for what we build. I also don't know anything about that. What we do at GitHub Next is we figure out what happens in the middle. We try to build prototypes and proof of concepts for projects that you will all use in the future. But we are not data scientists. We just use OpenAI models, as any of us can do. And we are not responsible for making full productized features that will then be part of github.com or something like that. We build prototypes. This talk will be divided into 3 parts. I will do a brief introduction to large language models in case you know nothing about them. That said, it will be really high level and without going into any details because I don't know those details. Then I will talk quite a lot about prompt engineering or prompt crafting, which is this new art or engineering, part of engineering, which figures out how to concatenate strings correctly. And then I will talk at the end about a bit more high level ideas about user experience, about how to measure success, whether you should at all use artificial intelligence in your projects, because that's a really good question. So large language model is a type of artificial intelligence model that was trained on a lot of text from the internet, all the text that OpenAI can find in the internet. They have many, many parameters, whatever it means. And yeah, they've been trained on a lot of unlabeled text. First of all, what is important that you need to remember is natural language processing model. You send into it bunch of English and you get bunch of English or any other natural language. English gets best results because there is most of text on the internet that they've used for training is English. It's probably those models are probabilistic. This means that you send an input to it once and it returns you something. Next time it may return you different result. This is really important in practice when you work with those models. You cannot easily write unit tests for that because those models are probabilistic. You cannot easily judge the correctness based on the single example. And that's why there's a lot of effort going into observability, telemetry, and such aspects while you are working on those applications. And I will mention that a bit more in the later part of the talk. And I think that what is also super interesting is that it's super fast-moving field. Every day there is something new. Every day there is new model announcement. Every day there is new whatever announcement. And also, even with existing models that has been around for a while, we still are every day discovering new techniques, how to communicate with those models, how to do prompt crafting, prompt engineering. So we are still discovering new stuff. This is all edge, kind of like new technology, fast-moving field. There's one thing that I should mention also before this slide. This talk will be fairly high-level overview. Like I cannot provide you with specific recipes for introduction AI to your application. It all depends. I think that's the most popular word or phrase that we've heard on this conference so far. But yes, it depends on your use case. Hopefully after this talk you will have high-level overview and will be able to find additional information for what you need to look for if you want to introduce large language models to your application. So another important feature, or kind of like feature of those models is something called context size or prompt size. As I've mentioned, what we do is we send text into those models, but we cannot send unlimited amount of this text. Those models are characterizing with something called context windows, and there are like 4,000 tokens, 8,000 tokens, 32,000 tokens, and well, new one is like announced on Monday was like 128,000 tokens, the new one from OpenAI. Token is between 2 and 3 characters. Like it doesn't really matter too much. Like there are like libraries that can easily calculate what is exactly token size of your input. What is important to remember is that those context windows, they include both input and output. So the more input you send to the model, the less space you have for output. The less input you send to the model, the more space you have for output. What is also important to remember is that the amount of text that you send to those models have huge impact on model performance, on cost of your processing, on latency of the processing. That means that while those 32K or 128K models feels like the natural choice and are most powerful, they may not always be a good choice for it. It all depends on your use case. Another really kind of like hyped term that has been around for a while now in AI space is this RLHF shortcut, which means reinforcement learning from human feedback. As I've mentioned, originally those large language models were just trained on like unlabeled data from internet. However, to create ChatGPT, OpenAI used additional training step where they hired a lot of contractors to generate like real conversations, to have like real training data on conversation. This means that those models that are characterized with this additional training step are way better at following instructions, are way better at use cases like chat. Again, that doesn't mean that they are universally better. It all depends on your use case. If you're building chat application, then yes, using model that was trained with this step is probably good. If you're building autocomplete, like GitHub Copilot, maybe that step in the training process is not necessary. And as I've mentioned, it's really interesting time. We can just use models from OpenAI or any other provider. We are using OpenAI for various reasons, like a lot of small green reasons. And there's a couple of those models. It's fastly moving space. I'm not going to go into details. Probably the most important thing on this slide is this QR code. If you want to learn more details about what is the state of the art from OpenAI, just follow the link, and there will be like list of models that you can access. What is important is that we, as a GitHub/Microsoft, we are using exactly the same models that you all have access here. We are not doing anything. We are not training the models on our own for Copilot. Those are the same, more or less the same models that you all can use. Which brings us to the next question. If those are the same models, how do we steer the behavior of those models? And this brings us to the second part of the talk, which will be a bit more in-depth, hopefully. Prompt engineering. So prompt engineering refers to the set of methods that we can use to communicate with large language models to steer behavior of the model in the direction that we want it to perform. So we don't want to just let model do whatever it wants. We want to provide right context to the model. What is the most important thing? It's just text. It's strings. Literally, string concatenation and string interpolation and like templating engines are core part of the work here. So it's not technically difficult. That said, it's still like engineering work. It's still research work in a lot of spaces. As I've mentioned, every day we discover new techniques. White papers are published every day to figure out what are the better ways of communicate, better ways of steering the behavior of the models. And I know that a lot of people on social media are kind of like memeing about like, oh, prompt crafting, prompt engineering, it's all about like writing some text into ChatGPT text box, but that's not really true. Again, it's kind of like research field and engineering field. So there's plenty of white papers about this whole field, and this whole field is characterized with one most important feature. People love to name things in a complex way, and those things are usually really simple. So in earlier version of my talk, I had those kind of like fancy sounding names, but I've decided to remove them and do something simpler for you. So first technique is called give examples to the model. That's really fancy. I don't know how visible it is. Should be okay. Yeah, as you can see here, in kind of like AI speak, it's called like zero shot learning. So we don't provide any example. All we do is kind of describe the task, and then model suggests something. Those green parts are kind of like what model is returning me. And it's doing something. It's doing pretty good job at response. But that said, I want to do something else. I want to do something more. And the good strategy for that is provide a couple of examples. If that would be the task, that would be my answer. If that would be the task, that would be my answer. And now the real task is this. What is the answer? And the models are really good at following patterns, at understanding the patterns that are in your prompts, in your examples, which means that the model response is indeed following the same pattern I described above. It's returning those descriptions of commands or arguments in this particular case. Quality of examples, number of examples, how examples are connected to your current task. This all have huge impact on the quality of the final result. So you need to play with that. You need to figure out exactly what are the right examples. There is also possibility of dynamically building the list of examples. So it's not always sending the same list of examples, but based on the user query, for example, sending examples that are more tailored to this particular user query. This is something we've done in one of our projects. The second thing that's, again, really simple idea is instruction prompting. Originally, those models were just good at finishing the sentences and kind of like finishing text. That was fairly terrible because you had to use quite a lot of tricks to kind of convince it to do what you want to do. But now you can just, in the text, describe exactly what you want to do, what you want the model to do. Please label the sentiments towards like whatever. Those models, especially the models with this like reinforcement learning with human feedback step, are pretty fantastic at following instructions. So this is pretty cool technique. You can also fairly easily mix it with the previous one, with providing examples. This was instruction, this was task, this is the result. This was instruction, this was the task, this is the result. Again, it all depends on your use cases. I cannot give you like final recipes for how to do that, but keep in mind those techniques. Another thing that those models are really good at is just returning JSON or YAML. Well, don't do that. JSON or any other structured format. We want to integrate, in many cases, we want to integrate the output from large language model into our system. Obviously, in case of chat, we just want to display it. But for example, in some other cases, we may want to put it into our database or put it into some logic that we have already in our system. And then, like, computers speak in JSON pretty easily. Like, we can easily parse JSON. Like, probably every one of us can know how to parse JSON in their programming language of choice. So just giving something like schema, and this is like really not really any kind of formal schema, but just kind of like description of like what are the fields and what can be the values in this kind of like JSON format or YAML format. Actually, like, jokes aside, YAML is terrible, but the models are really good at generating YAML. This is enough for model to be able to follow this instruction. So if you want to integrate the models into your like processing pipeline, whatever you have, that's a really simple way to do that. And probably the most interesting technique, it's called chain of thought in AI speak, is this idea that if you ask the model to reason about the problem, suddenly the results are becoming much better. I don't really, well, there is some research about exactly about why it's happening and so on. Basically, I think the core of the idea is that if the model is kind of like expressing step by step what it's trying to do, it's kind of less likely to hallucinate final result. But yeah, as you can see here at the top, there was this like random math question for like first class of primary school. It's super simple, and the original result was totally wrong. But if we ask the model to reason about it and do the process of thinking, and this is like quotes, thinking step by step, then the model suddenly is capable of coming up to the right result. This can be used both with like examples, but also if you don't have examples, just adding to the instruction, let's explain step by step, that actually makes a difference. So again, this is this example of those are small differences that you need to look at. This is really fast-moving field, so you need to be able to figure out those strategies. A lot of that is just playing with what feels good. Like for example, we discovered that the model are way more capable of following instruction if the instruction is positive rather than negative. If you say model to not to do something, it won't listen to you for some random reason. But if you describe what it should do, then it will. And there is like whole bunch of other techniques. Really, again, it's kind of like I don't want to go into details of every single one of those. There is something called self-consistency sampling. Basically, the idea is that you can ask the model multiple times for the same question, and then use some method of kind of like figuring out what is the right result from the set of results that you've got. Fairly often, majority voting would be good solution to this problem. So kind of like you get multiple results and you choose the one that's kind of like the same multiple times. You can the next step in this idea of reasoning is self-ask. You can ask model not only to explain itself, but also to ask questions to itself, like what should I do more? What should I do differently? This type of questions. And this again gives model a space to think about, quote unquote, think about the problems that you want it to solve. Tree of thoughts. So this is getting the idea of reasoning to the next level with some decisions trees and doing multiple calls to the models and then doing processing on those decisions, and it's a lot of stuff. Equipping with tools. This is really a hyped idea right now. So you may tell model that it is capable of executing some actions on behalf of users, doing Google search, executing some code. You get this response with special keywords that you defined in your prompts, where the model says, now I want to do Google search for this term. You do it for the model, then you send the response from Google search with your previous prompt again to the model, and the model have more context. It's kind of like giving model the ability to decide what it needs to do. Multi-round systems. I think that vast majority of our complex systems that we're developing right now are using multiple calls to the AI in a single like user action. So user is, let's say, invoking some action in GitHub interface or just in command line, and then we do one request. We process the response, we do another request, we process the response, we do another request, all in chain based on the next request is based on the previous response. And again, so on. Totally tons of white papers every day. It is fastly developing space. Now let's switch that a bit. There is also this term called retrieval or retrieval augmented generation, RAG, and it's probably the most popular buzzword among GitHub leadership / Microsoft leadership. If you know phone number to Satya, don't tell him that I've told you that. Basically, the idea is, or rather differently. So far, all the stuff that I've discussed were techniques for describing the constant part of the prompt. So the things that are kind of like description of the problem, description of the output, or maybe some kind of like small tricks like this. Let's think step by step. However, the real systems need also data based on your user, data based on the state of the system. In context of Copilot, what is the open file and what is the content of the file, and maybe what are the other interesting things from other files that you want to put the prompt. And this whole process is called retrieval. So it's all about taking the data from your databases, from your documentation, from your editor, all depends on your use case, and putting that into the prompt. There is no single solution. So I just want to mention this term so you can look more for the information and hopefully find something more. What is important here is that for many cases we discovered that depending on what model remembers from training is not actually the best solution, because models are prone to hallucination. Like we don't have a way to make sure that the things that model remember from training are actually true. Also, the knowledge that models remember from training may be outdated. Those models are getting trained for months, if not years. So that means there is a knowledge cutoff point. Model may not know latest version of the library. Model may not know what happened yesterday in the world. Retrieval allows us to put those more up-to-date information, more up-to-date, the live state of the system into the prompt. And also, probably the information that you put into the model with retrieval techniques, put into the prompt with retrieval techniques, are more accurate than what model remembers, because they are true data from your systems. So that means they are accurate rather than some model hallucination. So if you want a huge amount of accuracy, huge value of accuracy, you probably need to investigate or invest into the various retrieval techniques. And the one technology that is really useful while we talk about retrieval is this thing called embeddings. So embedding under the hood is just a vector, a list of floating numbers. What this vector represents is actual meaning of some sentence, and not only like descriptions word by word. It's not encoding. It also represents meaning of kind of this sentence is positive, this sentence is about software development, this sentence, so on, so on. There are AI models that transforms text into embeddings representation. And what is really nice is that when you have embeddings, you can compare them. It's just two vectors of string. You can calculate distance between them. If the two embeddings are close to each other, the distance is low. That means that those two sentences are somehow related to each other. And again, it's not about like textual word by word comparison, but it's more about like meaning behind the words. We use this technique, for example, in the project called Copilot for Docs. Copilot for Docs is a project where you have a chatbot and you can ask questions about documentation of particular project, for example, React or TypeScript. Based on the user query, on what you are typing into the chat, we are figuring out, using embeddings, we are figuring out what are parts of the documentation of React documentation or TypeScript documentation that are relevant to this query that you've typed. Thanks to that, we can put this relevant part of the documentation into the prompt, and we make sure that the results that you are getting are accurate, are not hallucinated. We also use this technique to make sure that in our responses, we can actually provide links back to the documentation. So you have further information or further proof that the information that we provide to you is correct. So yeah, so really, really interesting technique. It's again another fastly developing space, especially in terms of how to store those embeddings. There are special vector databases showing on the market right now, but also the traditional databases are slowly adding support for storing the vectors, which is probably the more promising for kind of like, especially for playing with it. Okay, so that was the part of really quick overview of like how to communicate with the AI and what the AI is and what exactly you want to put into it. And again, I know that this been super high level, but I cannot give you exact recipes. It all depends. So now let's talk about bit of kind of higher level ideas or higher level things you need to consider while you are working on the AI models or the projects using AI models. First of all, observing results. As I've mentioned, models are probabilistic. So how do I know whether my change to the prompt crafting that I've just done, I've added this like, let's explain step by step. How do I know that this is actually moving my prompt into the right direction? How do I know that I'm getting better results, higher accuracy, better latency? So this is like really difficult topic, and there's a couple of companies that are looking into that problem. Honeycomb, for example, which is the open telemetry guys. They are also investigating into like observability for AI. What we do is we have a couple of steps. First of all, we have offline evaluation framework. Basically, for every project that we developed, we also developed like offline evaluation framework. The idea is to take thousands and thousands of examples and run some kind of evaluation that tells us at a huge scale whether our changes are correct. Because often when we work on those systems, we change something in prompt crafting and we notice like 2% of accuracy change. So it's something that is hard to notice with just unit tests or anything like that. You need to observe the results at huge scale of thousands, tens of thousands, hundreds of thousands of responses. Doing offline evaluation is one of those ideas. For example, in case of Copilot, we designed a system where we clone a lot of Python repositories from GitHub. We take the repositories that have quite good test coverage. We find all unit tests. We make sure that tests are passing and kind of are in okay state to run. Then we go to the functions that those tests are testing. We remove the body of the function. We regenerate it with Copilot. We regenerate implementation with Copilot. And then we run unit tests again. And that gives us some kind of metrics that checks on the super huge scale of hundreds of thousands of functions whether our changes are correct. And then we just calculate it and see the percentages, and we are happy with ourselves or not. Another kind of probably a bit more controversial take is that you need to invest a lot into telemetry. It's the only way. You need to. I hate telemetry. I imagine that we all hate telemetry. Like software developers hate telemetry. We turn off telemetry in every single project, in every single product that we use. I know that. Unfortunately, it's the only way. Because even with the most complex offline evaluation frameworks, those results are not always the same as the results that we notice in practice. We invested quite a lot into A/B experiments, A/B frameworks that allows us to deploy different versions to the prompt crafting to different users on the scale of having hundreds of thousands of users or more. We are able to deploy some change to, let's say, 5% of the users and then measure difference without impacting the whole user base. And I think that this is probably the only solution really to observing results. Another thing that you need to remember is with the observing results is that the more accuracy doesn't necessarily mean more value for the users. Depending on your user experience, maybe latency is way more important for you. We had these problems with Copilot, where especially in the very early days of the Copilot, we noticed and we measured that using the faster models that give you slightly worse results is actually better. Because when we upgraded the models into the more powerful models using more prompt space, we noticed that we show less suggestions to the users because latency was way higher. And that meant that a lot of suggestions that would get accepted are just lost because people are keep typing in the editor. This is fairly specific to the type of the user experience that Copilot has designed with the like real-time suggestions as you type. But it's something that you should keep in mind. I think this link is to the white paper that some members of my team have published where we correlated the user happiness from like user studies that we've performed with the telemetry results for those users. And we've noticed also that for Copilot, users are really happy even if suggestion is slightly wrong, as long as this suggestion gives you a good starting point for moving forward. The worst thing in the software development is this feeling that you're stuck and you don't know what is the next step. Even if suggestion from the Copilot is not perfect solution to your next step, as long as it gives you some idea how to move forward, this is the value. So just aiming for accuracy, for 100% accuracy, which is impossible to be achieved, is not necessarily bringing you more value. And that also brings us a bit to the user experience design. That's something that is my kind of like specialty. Making sure that we enhance user capabilities rather than trying to replace the users is the core principle of everything that we should be doing with AI. We don't want to replace developers. You don't want to replace your users, because users that are getting feeling that they are getting replaced are unhappy users. They probably will stop using your product and stop paying you money. So all you do in terms of user experience needs to give a message to the user that it's all about enhancing user capabilities. I think I am slightly biased, but Copilot is a perfect example of that, right? You are still in the driving seat. You are still typing code in your editor. It's still the same environment that you've been using always. It's just a bit more powerful autocomplete, right? That means that there's like deep integration with inner loop of your user. So whatever user is doing nowadays is super important. User shouldn't be forced to learn too many new things. It's all about making the processes that user know already a bit more easier. Maybe AI will help them to start, write some query, for example. Maybe AI will help them to start writing some analysis of some business data. Maybe AI will suggest something to them. But it's all about the same processes. And another important thing is that those models are wrong. They will be wrong in some cases. They will hallucinate answers. All those techniques that that I've described here, all this like smart techniques and measuring results, those models will never be 100% accurate. That's kind of like how they work by design. That means that you need to design user experience defensively for failure. You need to make sure that user realizes that the suggestion or like whatever is the outcome of the AI may be wrong. You need to make sure that users can easily reject or edit user AI outcome. In case of Copilot, it's just pressing escape or even keep typing. That's all you need to do if the suggestion is wrong. You don't need to do anything special to reject the suggestion. So yeah, the design defensively for failure. Results should be fairly easy to ignore if they are wrong. They should be fairly easy to retry if user wants to retry and try again. Those models are probabilistic, so maybe retry will help. Users should have fairly easily ability to iterate on the results. So maybe the first initial results was wrong, but maybe just adding some more context will make the next result better. Copilot for CLIs, for example, using this technique to, if the first suggestion of the CLI command is wrong, then you can easily type another bit of context that we send to the model again with the previous response and previous prompt and this new suggestion, and then the model have more context to be able to figure out what you need. And also easy to modify potentially. So user accepted the result from the AI, but should be able to go back and modify the result. It shouldn't perform automatically after accepting some kind of super destructive actions on behalf of the user. It shouldn't, send money to someone from my bank account or anything like that. There are probably the three main types of the user experience that we've experienced or we've designed so far using for AI applications. One is optionality, so it's this like ghost text. That's not really super visible. I'm sorry about that. This is the ghost text is here. Imagine that there is this like ghost text, gray text in your editor. That's what we've been doing with Copilot. This sends clear message that this is AI generated content. This is easy to ignore. This is easy to reject. Another example could be transformation. So you select some text, or you select some data, or you select some, data, because that's the most generic way of describing it. And then you perform some AI-driven transformation. What is important is you should have ability to go back really easily to the previous state if this transformation was wrong. Or obviously the chats. I'm not the biggest fan of the chat interface, but for some cases, chat is really decent solution because it gives users ability to iterate on the results, to provide more context as you go. But you need to be careful because people very often, when they think about chat, they start to treating the AI they're chatting with as a human expert, and they start to trust responses from chat too much. We've seen that with ChatGPT quite often. So you need to be very clear that those results are coming from AI. Another thing that's worth considering is that those models are supporting streaming mode, when you don't need to wait for whole response. You can get response token by token using HTTP2 streaming capabilities. In some cases, you want to have everything at once. If you want to generate JSON that you will parse, that's probably you want to have complete JSON before you start parsing. But maybe if it's chat, then maybe streaming is good. Yeah, and again, the most important thing that you need to remember from this talk, well, no, that's the second most important thing that you need to remember from this talk. The most important one will come next. The second most important thing that you need to remember from this talk is that if you decided to build application using AI, large language models, or you want to integrate AI, large language models into your application, there is no single path to the success. It all depends. There are different techniques. You need to match and mix them. You need to learn how exactly they feel. You need to invest a lot into telemetry or observability, offline evaluation, to be able to measure the changes that you've made. And after this wonderful talk, you'll be here. There's whole mountain to climb. Making sure that your AI system is ready for production is a lot of work. There's a lot of infrastructure work. There's a lot of work on business side of things to figure out how to make money from this, because it's obviously quite high cost to introduce those models. So you will have adventure ahead of you. But probably the most important thing, the thing that I want to close this talk with, is a question. Should you even do that? I've spent, 42 minutes describing you how wonderful it can be and how easy it is, that you all need to do just web request and some string concatenation. But if some project manager, if some CEO comes to your team and says, let's introduce AI to our application because everyone talks about AI nowadays, your responsibility is to ask this question yourself and your CEO, decision makers. Should we do that? Those AI models will hallucinate. They are not 100% accurate. Is your use case okay with that? Can your users accept the fact that it's potentially incorrect? What happens if your model is incorrect? Would you want to get your tax returns be done with the AI model when the risk is that you will go to jail for tax malversation? Probably not. So if you do financial software, maybe using AI is, for this particular case, is not the best idea. Would you be happy if AI suddenly bought stocks for you that will go down? Probably not. Would you be happy if instead of meeting with doctor, you would meet with AI agent that will try to figure out what's wrong with you? Probably not. That said, there may be cases in the healthcare where the AI will be useful, for example, by providing additional context to the real doctors that are looking at you. So it all depends, and please do think about should you do that. And thank you for watching. That was Introduction to the AI.